Hi students, so we're going to do a little bit of review of stoichiometry. Stoichiometry is just trying to convert from one substance to another via a chemical equation. So what that means is when you've got something like H2O2 decomposes into water and oxygen. This is your skeleton equation, which doesn't have any balancing in it. If I want to balance it, I'll go ahead and put coefficients in front. So I can quickly just write out the different things that are in here. There's hydrogens on this side, there's 2 of those. On this side, I've got 2. But the oxygens are all messed up. There's 2 here and there are 3 here. So the way I'm going to fix that, I'm going to even the odd. So I'm going to take that odd oxygen and make it even. So now I have 4. There's 2 and 2 is 4. And now I'm just going to double this to make this 4. But now I've messed up my hydrogens as well. So now it's 4 and 2. It might seem like, well, how can I balance this or ever hope to balance it? But actually the 2 in front of there also has made that 4, which I had just forgotten to do initially. So I was going a little too fast there for myself, and there you go. There's the balanced equation, 2, 2, and 1. So that's important. The mole ratios are a 2 to 2 to 1, right? For the different substances that are in there. And this mole ratio is going to be my ticket to the stoichiometry process, the stoichiometric process. It's going to convert from one substance to another. I need to know that mole ratio. So let's say I had 25 grams of hydrogen peroxide, H2O2. And I want to know how much oxygen gas is that going to produce if it all decomposes. So the simple way of writing this out is that I've got my 25 grams of H2O2, and I'm going to want to get to grams of oxygen. So I'm starting here, I want to get to here. Well, how do I do that? Well, grams of this to the grams of that, I can't make that direct conversion. They're not the same grams. They're both going to be weight, but the weight of this gram is going to be a different weight to this gram because some of this mass is going to turn into water and some of the mass is going to turn into oxygen. And so because of the difference there in the breakdown, it's going to weigh differently than what it started out with. So it's not going to be 25 grams, it's going to be something less than that. Well, how do I convert from one to the other? First, I'm going to go from grams to moles, and then I'm going to go from moles to moles, and then from moles back to grams. So I'm going to do a moles to grams conversion, then I'm going to do a moles to moles conversion, and then I'm going to do a grams to moles conversion. Moles to grams conversion, I should say. And then I'll get my answer. So just to kind of outline that process, we've got our mole map. We call this mole island in my class too, but the mole map is basically you've got grams, you've got liters, and you've got representative particles. And to go to each island or each area, you need to do a conversion factor. So right now I'm going from grams to moles and then back from moles to grams. Why am I doing that? Because I have to change the type of gram I'm talking about based on the equation. I'm going to use the mole ratio to do that. So first, I go from 25 grams of hydrogen peroxide. I'm going to convert that to moles via the molar mass of hydrogen peroxide. So I can actually do this in my head. Oxygen is 16 grams each, and I have 2 of those, so that's 32. And these are 1 each. So I'm just doing the molar mass here. So that's going to be 1 times 2 equals 2. So 2 plus 32 is going to be 34 grams. I'm going to put that down here of hydrogen peroxide for every mole. I'm rounding with the 2 and the 32, but you're allowed to do the rounding so long as you're getting relatively close. The more precise you are, the better your number. But I tend to round, and I would just tend to round on homework and things like that, where you're just trying to go quick. On a test, it's best to be as accurate as possible. So use the full periodic table values that you can get to get the most accurate number, especially on a test. But for homework, sometimes rounding is okay. I think on the periodic table, this one's something like 15.99, and this one is 1.008. So I'm just rounding, rounding those values, as you can tell. All right, so 1 mole of H2O2 and 1 gram, or 34 grams of H2O2. So I'm out of these units, and I'm into these units. Now, what's the conversion? I'm trying to get to grams of oxygen. So I want to end up with grams of oxygen up here at the top, grams of O2. That's going to take me out of moles of O2, right? So I need to kind of get from moles of O2 to grams of O2. It means I need to get from moles of hydrogen peroxide to moles of oxygen. So what's the conversion going to be for that? Well, if I look at the reaction here, the conversion is 2 to 1, 2 to 1. For every 2 moles of hydrogen peroxide, I have 1 mole of oxygen, according to the equation, right? This is from the equation, from balanced equation, right? So if I do that conversion, I'm going to get into the moles of oxygen units that I want. And now I can just go from molar mass, from moles back to grams via the molar mass conversion. And O2 is 32 grams. Whoops, 32. 32 grams. So now I just take out my calculator and multiply the top, divide the bottom, and I'll get my answer. So my answer is 11.7, 0.76. What I'm going to do is round that to the sig figs that I started out with. So it's going to round up to 12 grams of oxygen. Okay, so what does that mean? If I have 25 grams of hydrogen peroxide, that will decompose completely via this chemical reaction. And when it does that, I'm going to get 12 grams of oxygen. Now, a very simple question could be, well, how much water are you going to have? Now, I could go through this whole process and figure out the answer, but that wouldn't really be necessary because I just know from conservation of mass that if all this decomposes in 12 of its oxygen, the rest is going to be water. So just another quick application of what I'm doing. I'm trying to break it down to see, well, I know the molar masses of these, I know their ratios, and I know how much of the reactant I start with. I can figure out the rest just by simple arithmetic. So that's the idea with stoichiometry, converting, and especially just going from grams to moles and moles to grams. You can also do the same with some of the other units. But again, what I have to use is this guy right here, the mole ratio. That's my magic conversion between one and the other. Sometimes the mole ratios are the same. You know, if I was going from hydrogen peroxide to water, the mole ratio is the same. So actually that conversion isn't going to do anything, but I will need to go from grams of hydrogen peroxide to grams of water. And because these weigh differently, that's actually going to be a different weight in the end. Even though the mole ratio is the same, the molar masses aren't. And so I'm actually going to have some different weights of water at the end, which, like we said, if we calculated it out, you could do it if you'd like. The answer would be 13. So anyway, that's just the way to do one of these mole ratio problems. The stoichiometry problems. I hope that's helpful to see it broken down that way.